Good day once again, everyone, and we are back together and looking at calculus this time around, looking at the cubic function. Of course, if you haven't subscribed, please just make sure that you're part of the family. And of course, your favorite uncle will continue to be your plug when it comes to, your preparation with regard to the maths exam that's coming up. All right, so we're going to be looking at the cubic function in this particular segment. All right, so let's just dive right into it. I took this one from the Gauteng Prelim exam, okay, 2022. So let's have a look at what it says. Right, so they say to us we've got a graph, the graph of h of x, which is minus x cubed plus ax squared plus bx plus c is sketched. All right, so we've got a and b, which are the turning points of h. And we've got t, which is 3 and y. They say it's a point on our graph. And then they say the graph h passes through the origin. Right, that's quite important because already it tells us that our c value, our y-intercept in that case is 0. Okay. Now, they say to us, show that a is equal to 12 and b is negative 36. Now, all right, so what we needed to do there, okay, so first of all, let's write down the equation in the form that it's written in. Okay, so we've got hx, so we start with 9.1. So hx is minus x cubed. Okay, all right, let me just write that nicely. So that's minus x cubed plus ax squared plus bx plus c, but we already know that our c value is 0, so we might as well just get rid of that part. Okay, right, now, so the first thing that we know there, we're given the turning point in this case, which is b, to be 6 and 0. So we know that when the graph of h, okay, when h is 6, okay, we know that the y value would be equal to 0, okay? So we know that that's going to be 6 cubed plus a times 6 squared plus b times 6. So I'm substituting the x value, but I know I'm substituting the point, in this case, as 6 and 0. So when x is 6, y is 0, so that will be equal to 0. All right, now let's try and get that there. Okay, so we've got 6 cubed. Okay, so we've got 6 cubed, which is 216. So we've got negative 216 plus 6 squared is 36a plus 6b. This is all equal to 0. All right, so let's try and get one of them to be the subject of the formula. In fact, what I'm going to do, let's divide everything by 6 in this case. So I've got 216 divide by 6. That would give me 36. So that would be minus 36 plus, divide that by 6. That will be 6a plus b. And this would be equal to 0. All right, so I'm going to try and isolate b and make it the subject of the formula. So in this case, I've got b is equal to negative 6a. Remember, when it goes to the other side, it becomes negative. Okay, plus 36. All right, so let's call that equation 1. All right, now, something else that we note there, that not only is that point b just an x-intercept in this case, in which case we substituted the point 6 and 0, but it is also a turning point. What do we know about the turning point? The derivative at the turning point is equal to 0. The gradient at that point is equal to 0. So it means if we took h dash of x, right, at that point where actually h dash of 6, right, where x is equal to 6, we know that this would be equal to 0. So first of all, let's find the gradient in this case, formula. So h dash of x, this would be negative 3x squared plus 2ax. At this stage, I would expect you, ladies and gents, to be able to obviously find the derivative. plus b in this case. And so I'm going to say, let's substitute 6 there. So that's minus 3 times 6 squared plus 2 times a, okay, so let's write that nicely there. A times 6 plus b, all of this would be equal to 0, right? Remember, that's at the turning point in that case. So we've got 36 times 3, which would be minus 108 plus 12a rather, okay, plus b, and this is equal to 0. And of course, once again, we can isolate b in this case and make it subject of the formula. So I'll have minus 12a plus 108, right? So let's call this equation 2. What do we note? Both equation 1 and 2 are equations in terms of b. So it means that equation 1 is equal to equation 2. So I'm going to take the right-hand side of each equation and equate it to each other because they basically represent the same thing. So that's minus 6a plus 36 is equal to negative 12a plus 108, right? Okay, so let's take the 12a to the other side, it becomes positive, and the 36 to the other side, it becomes negative. So we've got 12a minus 6a, which would give us 6a, and 108 minus 36, okay, just to make sure that I'm absolutely correct, minus 36, that would give us 72, okay? So divide both sides by 6, and of course, you can see how a would be equal to 12. Okay, right. It's actually, yes, a is equal to 12. And of course, to get the value of b, all I'm going to do is substitute a is equal to 12, okay, into equation 2. It doesn't matter whether you substituted it in a, in equation 1 or 2. So b would be equal to negative 12 times 12 plus 108, okay? So that would give us minus 144 plus 108, okay? So let's get the difference there. So that's 144 minus 108, and of course just remembering to make it negative because the bigger number is negative there. So you can see how b will be equal to negative 36. Okay, right, so we have proven what they asked us to prove, that a is indeed equal to 12 and b is equal to negative 36, right? Now the next question, they say calculate the coordinates of a. So it means we're looking for the other turning point now, right? So what I'm going to do, now that we know the equation, okay, so that would be 9.2 actually. Okay, so for 9.2, now that I know the equation of h of x, right? So that's going to be minus x cubed, right, plus 12x squared minus 36x, right? So I'm going to take the derivative. Of course, in this case, I'm expecting that one of those values obviously will be at that value where x is equal to 6, was it? Our turning point that was given. Yes, x is equal to 6. Right, so h, okay, we take that derivative, that's minus 3x squared plus 24x minus 36, okay, and we know that the derivative is equal to 0. Right, we're going to divide everything by negative 3, so we get x squared minus, please remember it changes sign, okay, 24 divided by negative 3 in this case, so that would give us minus 8x, okay, and divide plus rather 12, and so this is equal to 0. Right, so we can factorize there. factors of 12 such that when we add them, we get 8. Definitely that would be 6 and 2, isn't it? So that's 6 and 2. Okay, and by the way, that's a positive sign there, so it tells us that the signs inside the brackets are the same. So which is the sign? It's the sign of the middle term. So that's going to be negative and negative, and so x is equal to 6 or x is equal to 2. Of course, this is not the one that we're looking for. In this case, we're looking for that solution there, right? Now, to get the coordinates, which is what they wanted, right? They said calculate the coordinates of A. So to get the y value of A, I'm going to substitute that x value that we got into the original equation. So h of 2 in this case would be minus 2 cubed plus 12 times 2 squared minus 36 times 2. Okay, right, so in this case I've got that's minus 8 plus 12 times 4, that would be 48, minus 36 times 2, that would be 72. Okay, so let's try and find that out. So that would be minus 80. Okay, so that would be negative 80 plus 48. You guys have been accusing me of making mistakes, so rather I choose to use my calculator just to be safe. Or as you guys would say, so to safety. Okay, right, so my value there is negative 32. Please, if you can, verify that for me. If I did make an error, please do forgive. All right, so it means that the value there, right, or the coordinates are 2 and minus 32. Okay, right. Okay, so we have got, right, so we have got the coordinates of that A, which is our turning point. All right, now they say to you, calculate the value of y. Now remember that y is actually a value where x is equal to 3. So all I'm going to do is substitute x is equal to 3. So 9.3, I'm going to say h of 3. That's going to be minus 3 cubed, right? Plus 12 times 3 squared minus 36 times 3. Right, so let's try and get that value there. So that would be negative 27. Okay, so let's do this. Negative 27 plus 12 times 9. 3 squared is 9. Minus 36 times 3. Okay, so I get a value of negative 27. Okay, so it means that y is equal to negative 27. Right, so looking at the next question. Now, they say to us, is the graph of h concave up or concave down at t? Now remember, t is equal to 3 there, right? So it's equal to 3. So we want to know, is the graph concave up or concave down? Now there are two ways of doing this, all right? And please, I want you to listen carefully. Remember, what separates the two points on the graph where it is concave up or concave down, that's the point of inflection, right? So we need to find out what the point of inflection is. So it would mean anything before the point of inflection would be concave up. Anything after the point of inflection, as you can see, in this case would be concave down. But there is another way of testing for that, and I'm going to show you that in a little while. Okay, so for 9.4, so we find the double derivative, right? So we're going to say h dash of x. Okay, so that's going to be minus 3x squared plus we said that's going to be 24x, right, minus 36. Okay, that's, yeah, I am correct. So that's minus 36. Okay, so that's going to be the derivative, but we want the double derivative. Remember, to get the point of inflection, right? In this case, it could be the double derivative. Now, if we knew, oh, and by the way, yeah, we actually do. We know both turning points in this case. So the point of inflection would be actually the midpoint between our x-intercepts. Sorry, our turning point, x values of the turning point. I'm going to show you that later, right? So a double derivative in this case would be minus 6x plus 24, right? We say the double derivative is equal to 0 at the point of inflection. So it means that negative 6x would be equal to negative 24. If I divide both sides by negative 6, I get x is equal to, right? So that's 24 divided by negative 6. Negative 24 divided by negative 6 would give me x is equal to 4, right? By the way, you could also get that. Remember, I said you could get that by finding the midpoint between your the x values of your turning point. We already found out that the other turning point was at 2 and the other one was at 6. So if you say 6 plus 2, in this case would give you 8, divided by 2, that would give you 4. All right, so that's another way of finding that. Okay, right, now, remember, we wanted to find out that x is equal to 3. In this case, it would mean that, you know, it would actually be concave up, right? Because that's before the point of inflection, right? So it would be concave up. But as I said, I'm going to show you also how to test for that, right? So what you do is you take the double derivative. So the double derivative at 4, okay, in this case, sorry, at 3 rather, the double derivative at 3, meaning I'm substituting that value to check, right? So in this case, that's going to be, our double derivative was minus 6 times 3, that's x, plus 24, okay? So that would be negative 18 plus 24, and that gives you a positive 6. Now, please, I want you to listen carefully, ladies and gents. When the double derivative is greater than 0, meaning if it's a positive number, then it tells us that the graph is concave up, okay? Which is, by the way, what we got as well, because it's before the point of inflection. So at x is equal to 3, it means that our graph is still concave up, right? But if we worked out and we found out that the double derivative is less than 0, okay, then it means at that point it is concave down. Okay, right, so in this case we found it to be greater than 0, so it means that it is concave up. So it means at the graph is concave up at x is equal to 3. Right, I hope that made sense. Right, so the last question, they said determine the coordinates of the point of inflection, right? We've already found the x value of the point of inflection, which, by the way, we found that it was x is equal to 4. So all we can do now is find the y value, right? So our previous, so that is 9.5. So we're going to say h of 4, right? So we go into the original equation. That's minus 4 cubed plus 12 times 4 squared minus 36 times 4. Am I correct? That's our plus 12. Okay. Right. So in this case, all we simply do, okay, I'm going to be lazy and just put that in my calculator. So that's 4 cubed, okay, plus, that's 12 times 4 squared, minus 36 times 4, and in this case we get negative 16. So it means our point of inflection, okay, so inflection point, okay, the coordinates are when x is equal to 4, y is negative 16, right? So I hope that really made sense, ladies and gents, that you were able to follow as I took you through this question. And of course, please, you're more than welcome to send through even more suggestions on things that you are struggling with. I will be hosting a live session probably tomorrow just to help you through just those last minute preparations, okay? But I will announce on that. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.